السلام عليكم ورحمة الله وبركاته. My name is Amani Muhammad. Our lesson today is mapping functions for grade 9. Okay, let's start. Hello, grade 9. How are you today? Who ready to start our lesson today? Yes, let's start. Here, I have very easy question in this game. Who try to play with me? Okay, Ahmed, let's start. Choose your box. Number 1. The number of football team. Yes. Okay. Who else? Duha. Yes. Number 3. The sunrise from. Okay. Who else? Mona. The capital of England. We know that. We know that each question here has a unique answer. Isn't it? Yes, right. And we should solve each question to pass to the another part of our session. Okay. Our lesson today is mapping functions, and our objectives is.
Today we will learn, determine the relation. Is a function or not?
Yes. Now, we have very important video, so we must pay attention. Then we discuss it.
We know that a relation is a set of ordered pairs that satisfy a relationship. This was the Cartesian product of sets P and Q we'd seen previously. And this is set R dash. There's a relation here. The second number here is a multiple of the first in each case. Now let's talk about the terms image, range, domain, and codomain. We know that the set R dash has 3 ordered pairs, 2, 10, 2, 20, and 4, 20. Here we can say that 10 is an image of 2, 20 is an image of 2, and 20 is an image of 4. We can say that every Q in set R dash is an image of its P. The set of P of all ordered pairs P, Q in set R dash is called the domain. Or we can say that the set of the first elements of all the ordered pairs in set R dash is called the domain. So we can say that the domain contains the elements 2 and 4. Now it would be very easy to guess what range means. The set of Q of all ordered pairs P, Q in set R dash is called the range. Or we can say that the second elements of all the ordered pairs in the relation R is called the range. The range contains the elements 10 and 20. So all the first elements form the domain and all the second elements form the range. What is the codomain here? The whole set Q is called the codomain of relation R. So the codomain here will contain the elements 10, 20, and 35. Easy, wasn't it? Now I want you to look at the range and the codomain and find a relation between them. What can we say? We could say that the range is a subset of the codomain. Here is an arrow diagram to learn what is domain, range, and codomain. So, this is the domain.
Who told me the domain here is the first set, which is P, 2, and 4. Codomain here is the second set, is its elements is 10, 20, 35, and the range here is 10 and 20. Okay, let's start. let's
This is the
continue.
range, and this is the codomain for a relation R.
Here we have two sets, and the relation between these two sets is 1 paired up with 3, 2 paired up with 5, and 3 paired up with 7, and 4 paired up with 1. Okay? Okay. Who tell me the range here? Who? Yes. Smart. Okay. 1, 3, 5, 7. Yes. Who tell me the domain here? Muhammad? 1, 2, 3, 4. Very good. Who else tell me the codomain here? 1. Okay. Adil. 1, 3, 5, 7. Very good. Okay. Here we have relation between the input set and the output set. Our input set is negative 1, 0, 1, 2, 3, and the output set is 3, 5, 11, and 21. The relation here between the domain is negative 1, 0, 1, 2, 3, and the range, which is, who tell me the range here? Yes, 3 and 5 and 11 and 21. Okay. Also, the co-domain here is 3, 5, 11, and 21. Okay. Also here, the domain is 1, 2, 3, 4. Co-domain is A, B, C, D. But the range here is, Mona? Yes, B and C and D. Very good. Okay. Here, in each of these relations, we have condition is common between the three relations. Who tell me what is the condition here which common between the three relations? Okay. Write in chat box, please. Okay. Okay. Yes. Then who tell me? Yes. Rida? Yes. Yes. Each element here in the first set has one image in the second set. Also here, each element here has an image in the second set. Also here, each input here in the first set has output in the second set. Okay. So we can say that these relations are functions. But why these relations are functions? Because each function is a relation between two sets. The first relation, its elements here has one and only one image from the second set. Okay? Okay. So number 1 here has one image, number 2 has one image, number 3 has one image here, and number 4 also, and so on here and here. Okay. Who tell me, is this relation is a function or not? Yes. Okay, Ahmad? Yes, very good. It's not function because we said that the relation to be a function must each element of the input set has image at the output set. Okay? Okay. Here, element of number 3 hasn't any images of the input, the output. Also, number 1 here is the element of the first set has 2 images in the output set. Okay, not one image. So it is not function. Here also, not each element of the first set has image in the second element of the second set. So we can't see we can say here this relation in function. No, this relation is not function. Okay? Who tell me this relation is function or not? And why? Okay? Ahmed? Yes. Very good. This relation is not function because the first element here has more than one image in the second set. And so it is not function. Okay. Our rules in this session for any relation to be a function as this: every x value or input has exactly one y value or output as here. It's okay if different x values pair up with the same y value. As here, 1 and 2 and 3 has the same image. Okay, it's okay, but each element here has only one image. Okay? Okay. So it's not okay here in this function, in this relation, because the first element here has two images. So it's not function. Here, our exercise. Don't forget that each element of the set of X appears only once. Let's start. Who tell me this function, this relation is a function or not? Ahmed? Yes? Yes, very good. It's a function because each element in the first set has one image in the second set. Okay, and each element here appear also. Here, who tell me it's a function or not? Yes? Sama? Okay. Very good. It's not function because, yes, very good. Because here, number 6 has two images in the output. Okay. Here, who tell me function or not? Yes, amazing. It's a function because each element here only appear one time. So the first one is function, second one is not function, third one is function also. Here, who tell me function or not? Yes, not function. Okay. And here not function because number 9 has two images. But here not function because number 3 hasn't images. Okay. Here our activity today, we will divide it to two groups. Each group has one relation and discuss if this relation is a function or not. After that, we will return to discuss our solution. Okay? Okay. Who tell me each group has two relations? No, one relation. Yes. Who tell me each group in his activity discuss if this relation or not? No. Each group discuss if this a function or not. Yes, very good. Let's start. Okay. Turn back, please. Okay. Here, the first relation, we found that each element here, 1 and 2 and 3 and 4, are appears from 1, 2, 3, 4 is the input set or x-axis. Okay, so and only appear one time. So the relation 1 is a function because each element of the set of X appears as a first projection only once. Okay? Okay. Who tell me from the second group, relation R2 is function or not? Yes, it's not function because element one of the second X appears as first projection twice. And also element 3 of the X set doesn't appear. Okay? Okay. Here, our summary. The function is relation. Each input has one output. Don't forget this. Here, our evaluation or our homework. Please take this link to your chat box, please. Then solve it. Okay. Okay. Also, solve your student book, page 32. Then photo your solution and send your answers on this link on Padlet. Okay? Okay. Here, who tell me what is this in this picture? Yes, this is laptop. Then, who tell me how do you apply the function rules on the computer device? Search, then I will discuss with you at the another session. Okay, thank you very much.